Okay, so now we are going to discuss about topic 7, probability. We have two subtopics only, events and probability for the first subtopic, and the second one will be conditional probability. So we're going to see the learning outcome you're going to have from the first subtopic. Recognize the concept of experiments, outcomes, sample space, events, and random solutions. Relate events as a set and use the basic set operations to define outcome of events. State the basic laws of probability. Find the probability of events and determine the probabilities of the intersection and union of two events. Okay, so I just want you to know that so we have some terms that you need to know. You need to be clear. We have about the experiments, outcomes, sample space, and events. Okay. What is random experiment? Random experiment is a process leading to a least two possible outcomes with uncertainty results. As an example, a coin is thrown, so either we'll be having head or tail. A dice is rolled. Okay, the result will be one of the numbers, either 1, 2, 3, 4, or 6. Okay, and then which is after some experiments. We are going to have the outcomes, which is we are going to call it as a basic outcomes. And then all the sets of basic outcomes, we are going to call it as a sample space. Okay, so we're going to see here, the possible outcomes of random experiment are called the basic outcomes. Okay, and the set of all basic outcomes is called the sample space. The symbol S, capital letter of S symbol is defined, will be denoted as a sample space. Okay, so we're going to see, this is just some example. The dice is rolled and so on. It's okay, I'm going to give some example later. I'm going to relate everything, all the terms here later on. Okay, events is what? Events is a subset of a sample space, which is events is a set of outcomes that satisfy certain specific conditions. Okay, so I'm going to give some example here. Okay. Let's say we're going to start with experiments. Okay, the first one we are going to start with experiments. Okay, the experiments here. Okay, the experiments, which is as an example, one experiment that you are going to do is having a dice. Okay, we know from a dice we will be having we will be having 1, 2, and then 3, and then we have 4, 5, and then 6 surface, right? From the experiment, you are rolling a dice. Okay, you now are rolling a dice. Okay, so after you are rolling a dice, and then you are going to have some outcome. The outcome from rolling a dice. Okay, I'm going to have this one. The outcome from rolling a dice. So the outcome is you are going to have either 1 or 2 or 3 or 4 or 5 or 6. So you'll be having this one, right? Either you are getting 1, 2, 3 or 5 or 4 or 5 or 6. And then the next one, after you've got the outcome, what we are going to do with the outcome? So we are going to do the outcome with what? We are going to make it as a sample space. How can we going to have the sample space? The sample space is all the outcomes that you have. So we are going to denote it as a capital of S. So we could have this one. So put a set here, open curly bracket here, and then we're going to have the outcomes as 1, 2, 3, 4, 5, and 6. So I'll close the bracket. So this is your sample space. So after you've got the sample space, okay, so after you, okay, now I'm going to repeat again. So an experiment, now you are doing some experiment. An experiment is you are rolling a dice. You are rolling a dice, and then after you roll the dice, you are going to have the outcome. So the outcome you'll be having from 1, 2, 3, 4, 5, or 6. And then what we are going to do with the outcome? So the outcome we are going to write it as a sample space. Sample space we are going to denote it as a capital of S here. So we are going to have a set. In the set of sample spaces we will be having 1, 2, 3 until 6. And then the last one, what is events? Event, as an example, what I want you to have is, let's say you are rolling a dice and you already have the sample space, right? And now the next one, I want you to just have even number. Okay, to get an even number, so you'll be having maybe I'm gonna have the events A. Events A is getting even number. So events A, I'm gonna have only either 2, 4 or 6, which is all the events A here. We can get it from the sample space. Actually, events is a subset for the sample space. Or maybe I'm gonna have events B. What is events B? Maybe I'm gonna have odd number. So events B will be having 1, 3 and 5. So there you are. I hope you are clear. So we are going to start from the experiments. After you did some experiments, you'll be having the outcome. So after you've got the outcome, so you'll be having the sample space. The sample space is, you've got it from the outcomes there, right? The sample space is all the outcomes. Okay, all the outcomes that you have. Okay, after you rolling a dice there. And then the events is what? Event is a specific experiment that you want. Okay, as an example, maybe from rolling a dice you just want an even number, so the probability that you can get is 2, 4, 6. Okay, so about the probability, so after you've done this one, so we are going to move about the probability here. Okay, so for the probability, let's say you are having event A, even number, which is you just have 3 here, 2, 4, 6. So we'll be having 3 out of the sample space, which is 6. So we'll be having 1 over 2, which is the probability will be 1 over 2 for the event A. What I want to remind you here, which is this part, probability. Okay, probability here, it must be in between of 0 and 1 only. Either it is equal to 0 or 1, but it must be in between of 0 and 1. As you can see from here, the probability that we've got is 1 over 2, which is 0.5. If 0.5, it will be in between of 0 and 1. It must not more than 1, must not less than 0. I hope you are clear about the probability here. So we are going to proceed for the next one. Okay, as I told you just now, probability of events, okay, S is sample space of an experiment. Then probability of events A written as PA. Okay, P is defined as probability. A, capital of A is here. We are going to know it as event A. Is defined as number of A over with number of S, as what we did just now. What we did just now. Let's say you are rolling a dice, right? You are rolling a dice. And then for the event A, you want to get even number. Okay, even number. So you know you'll be having events A will be having 2, 4 and 6. Okay, and the sample space that you have, you are going to have 1, 2, 3, 4, 5 and 6 here. So the total is 6. So you know you just want total A, right? So you will be having number of A is 3. Okay, number of A is 3. And number of S is 6. So you'll be having 3 out of 6. So you'll be having 1 over 2 that already discussed just now. So this is how can we use the formula. So you can see from here, please highlight this part. I already tell you here, which is the probability must be in between of 0 and 1 only. It must not less than 0, must not more than 1. So this is the proving. I'm not going to discuss this one. Okay. Which is another one example that you can see from here. Okay, if one ball is taken from a bag containing only red balls, so you already read over here, you are having in one bag only one ball, which is the ball is red balls, and if you are getting the probability to get the ball is red is 1, and the probability to get the ball is blue, of course 0, because there is no blue ball in this case. So let's see it together for the example 7.1. Okay, for example 7.1, given to you, find the probability of obtaining a number greater than 4 on a single toss of a dice. Okay, as we know, to get number, to get more than 4, you'll be having 5 and 6, which is these two numbers. So the sample space that we're having, which is 1, 2, 3 until 6, means we are having 6. And events of getting a number greater than 4 is A. It said A here will be 5 and 6. So the number of what can we say? the number of possible outcomes in A will be having 2. So 2 out of 6 will be equal to 1 over 3. So the probability here is 1 over 3. I hope you are clear about this part. Let's move for the next one. Okay, so this is the basic laws of probability. Complementary events, which is A bar. The meaning of A bar be the events of A does not occur and the S is a sample space of course. Then the probability of A bar here, it will be equal to 1 minus probability of A. Okay, as an example, maybe you can have it in this way. So events A, okay, maybe you are rolling a dice. So in this case, our experiment is rolling a dice. Now we are having some events. So the dice is 1, here 2, and here 1, 2, 3, and so on. Okay, so the sample space is, we're going to have 1, 2, 3, 4, and 5, and 6. And now the events A that I'm going to have is even number. Okay, even number. But now what I want is, okay, so we will be having probability of A. Okay, I'm sorry here. So we'll be having probability even number. Of course, we'll be having A here will be equal to 2, 4, and 6, right? So probability of A, it will be equal to number of A is 3 out of 6. So probability of A, it will be equal to 1 over 2. So now if you want to find probability of A bar, we can use this formula, which is complementary events here. We can have in this way 1 minus probability of A here. So 1 minus 1 will be having 1 minus 1 over 2. It will be equal to 1 over 2. So 1 over 2 is your probability of A bar. So I hope you are clear about this part. So this is just some proof that you can read by your own. I'm not going to explain. Which is another one way that we can write or we can call the A bar here. We can denote it as A. We have some symbol here at the above here, or A power of C here. Okay, so that's all. Which is we are going to proceed for the next example. Example 7.2. Okay, let's say Karim has a set of 8 cards, numbered 1 to 8. A card is drawn randomly from the set of cards. Find the probability that the number drawn is 8. So we know the event A getting number of 8, A bar, which is you are not getting number of 8. So the sample space is from 1, 2, 3, 4, 5, 6, 7, 8. And event A will be having 8, which means we will be having number of A is equal to 1 out of 8. And probability of A bar here, A bar, you can just have 7 out of 8. Or you can just use the formula, probability of A bar will be equal to 1 minus probability of A will be equal to 1 minus 1 over 8 is equal to 1 7 over 8. So I hope you are clear about the complementary events here. And let's move for the additive rule of probability. Okay, additive rule of probability here, you can see from here we are having 2 events, which is the condition that we must fulfill is the probability must not equal with 0. So which is the probability of the union of 2 events, we will be having this one. Probability of A union B, it will be equal to probability of A plus probability of B minus probability of A intersect with B. Where A union B is the events that A occurs or B occurs, or both events A and B are occurs. A intersect with B is the events that both A and B occur together. Okay, so you can see from here, this is the proving, which is at the left hand side here on how you can get the formula. Probability of A union B will be equal to probability of A plus probability of B minus probability of A intersect with B. As we are having another one proving using the diagram, which is this one. Okay, maybe you I'm gonna show you a little bit here. Okay, so let's say we are having this diagram to show that events set A and set B. Okay, so let's say I'm gonna draw here. If you try to look at the formula, we'll be having probability of A plus probability of B minus probability of A intersect with B, right? So we know that probability of A, maybe we're gonna have some red color here. So I'm shading with a red color. This is for the set A, and for the set B, we'll be having the blue color here. So as you can see from here, we'll be having some overlapping here, right? There is some overlap between A and B, which is this is the intersection between these two is A intersect with B. So since it is overlap, so we need to minus one of the overlap here, right? So we just want either we're gonna have this one, we are going to minus this one. So that's why we'll be, so you can see from here, all the region, all the figure here, I mean all the sets here already shaded, right, by the blue and the red color, and there is no